Welcome to World of Maths. Today we will continue our discussion on real numbers. We will see one of the very important property of real number, which is called the fundamental theorem of arithmetics. To know more about fundamental theorem of arithmetics, we should know what are prime numbers and composite numbers. I know we have covered the prime numbers and composite numbers in your primary grades, but let's revisit this very quickly. So what are prime numbers? The numbers which have only two factors are called prime numbers. The numbers which have only two factors are called prime numbers. I have done a separate video on factors and multiples. Please do watch so you will be clear on what are factors. The link is added below the description box. So, and what are composite numbers? The numbers with more than two factors are called composite numbers. Let's understand this with few examples. Let's look into the natural numbers from number 2 to 10. Number 1 is neither considered as prime number nor composite number. 2 we can express 2 as the product of 2 multiplied by 1. The factors of 2 are 2 and 1. If you look into number 3 can be expressed as the product of 3 multiplied 1, and the factors of number 3 are 3 and 1. We have seen the numbers which have only two factors are prime numbers. See number 4. 4 can be expressed in two different ways. One is 4 multiplied by 1 and 2 multiplied by 2. Hence 4 has three factors which are 1, 2 and 4. So 4 is not a prime number. 4 is considered as a composite number. Composite numbers are numbers which have more than two factors. If you look into the first 10 numbers, number 2, 3, 5 and 7 are prime number as these have only two factors. And 4, 6, 8, 9 and 10 are composite number as these has more than two factors. Let's see the connection between prime number and composite number. Prime numbers are considered as the building blocks of composite number. Reversely, we can say every composite number can be expressed as a product of prime numbers. So now we know what is the fundamental theorem of arithmetics. Every composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique apart from the order in which the prime factor occurs. We have seen what is fundamental theorem of arithmetics. Let's see the application of that theorem in mathematics. Let's see number 156. Number 156. We can express 156 as the product of prime numbers. For that we need to know what are its factors. Let's prime factorize 156. If you do prime factorization of 156, you will get 78 can be divided by 2 again. 39 can be 3, 13 and 1. So we can say 156 can be expressed as 2 multiplied by 2 multiplied by 3 multiplied by 13 multiplied 1 will give you answer 156. As the theorem says that there is no specific order, we can reorder these numbers, reorder the factors. We can put 3 times 13 times 2 times 2 times 1 will give you also the answer 156. So we can say all composite numbers can be expressed as the product of prime numbers in a unique way apart from their order. Let's see one more number, number 112. If we prime factorize 112, we will have 5, 6, 2 will give you 28, 2, 14, 2 and 7, 1. So 112 can be expressed as 2 multiplied by 2 multiplied by 2 multiplied 2, 7 multiplied by 1 will give you 112. Even if we change the order of the factors, like we can write 7 into 2 into 2 into 2 to 2 multiplied 1 will give you also 112. So the order doesn't matter. Every composite number can be expressed as a product of prime numbers in a unique way, apart from the order. I hope you are clear on what is the fundamental theorem of arithmetic. Now let's see the application of this theorem in how to find the HCF and LCM of numbers. We have seen number 156 can be expressed as a product of its prime factors, and 112 can be expressed as the product of their prime factors. To simplify this, we can write 2 times 2, which is the same. We can take the power of 2. 2 to the power of 2 multiplied by 3 into 13 times 1 will give you 156. Instead of writing 2 multiplied by 2, we can write 2 to the power of 2. Here it will be 1. How many 2s is here for 112? We have 1, 2, 3, 4. So 2 to the power of 4 times 7 times 1 will give you 112. So this is the basics of fundamental theorem of arithmetic. Now let's do a question. Find the LCM and HCF of 6 and 20 by prime factorization method. 6 can be expressed as 2 multiplied by 3. The factors of 6 are 2 and 3. And 20 can be expressed as 2 multiplied by 2 multiplied by 5. Factors of 20 are 2 and 5. Here we can see the common factor is number 2. And there is only one common factor for 6 and 20. Hence the HCF of 6 and 20 is 2. If we look into the multiples of 6, the table, we know the multiplication table of 6. I have written from 6 to 60. And multiples of 20 are 20, 40, 60 and 80. Here the lowest common multiple of 6 and 20 is number 60. Hence the LCM of 6 and 20 is 60. From this question we can say HCF of 6 and 20 is 2. So the product of the smallest power of each common prime factor. HCF of two numbers is the product of the smallest power of each common prime factor. In the above question, the common factors are 2 to the power of 2 and 2 to the power of 1. And the smallest power is 2 to the power of 1. Hence, the HCF of 6 and 20 is 2. And LCM of 6 and 20 is number 60. We can say LCM is the product of the greatest power of each prime factor involved. The prime factors involved for both these numbers are 2, 3 and 5. If we look into the powers, the highest power of 2 is 2 to the power of 2, and for 3 is 3 to the power of 1, and for 5 is 5 to the power of 1. To find the LCM of 6 and 20, we need to multiply the greatest power of each prime factor involved. So 2 to the power of 2 multiplied by 3 multiplied by 5 will give you the answer 60, which is the LCM of 6 and 20. From the previous question, we can also see that the given numbers are 6 and 20. The product of the given numbers is 6 multiplied by 20, which is equal to 120. And the LCM and HCF are 60 and 20. If you multiply, the LCM and HCF will also give you the same answer, 120. So we can say that for any two positive integers a and b, HCF of a and b multiplied by LCM of a and b is equal to a multiplied by b. Now let's do one more question. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. Using the prime factorization method, we know the factors of 6 are 2 and 3. 6 can be expressed as 2 multiplied by 3, and 72 we will get 2 multiplied by 2 multiplied by 2 and multiplied by 3 and multiplied by 3, which is 2 to the power of 3 multiplied by 3 to the power of 2. If we prime factorize 120, we will get 2 multiplied by 2 multiplied by 2 multiplied by 3 and multiplied by 5, which is 2 to the power of 3 multiplied by 3 to the power of 1 multiplied by 5 to the power of 1. Here we can see 2 to the power of 1 and 3 to the power of 1 are the smallest power of the common factors 2 and 3 respectively. So, the highest common factor of 6, 72 and 120 is the product of the smallest power of common factors, which is 2 multiplied by 3, which is equal to 6. For the lowest common multiple, we can see the greatest power of prime factors involved are 2 to the power of 3, 3 to the power of 2 and 5 to the power of 1. So, the LCM of 6, 72 and 120 is equal to 2 to the power of 3 multiplied by 3 to the power of 2 multiplied by 5 to the power of 1, which is equal to 360. To summarize, we can say HCF is the product of the smallest power of each common prime factor. LCM is the product of the greatest power of each prime factor involved. And for any two positive integers a and b, HCF of a and b multiplied by LCM of a and b is equal to a multiplied by b. In my next video, I will be covering exercise number 1.2. Make sure you click the bell icon so you will not miss it. Please like, share and subscribe, and thank you for watching.